Hey, everybody, welcome back to your Full Crew podcast. I am Dawn Zoldi, your host, CEO of P3 Tech Consulting, and publisher at Autonomy Global. And we have dedicated this month to the theme of autonomy. We've got some great articles and amazing guests and incredible sponsors. So let's go in that order. The articles we're going to be talking about, and by the way, this isn't in the order of which we will be speaking about them, but we've got GNSS denied UAV navigation. We'll be talking all about that and kind of the implications and what the tech is out there behind that. We've got the ethics of autonomous weapons systems on the defense side. And then we're also going to be talking about network RTK and how that enhances global positioning accuracy. So to speak about these topics, we've got three amazing experts. But before I have them do their 30-second elevator pitch bios for you, I'm going to thank our three sponsors, actually. We have got Rollins Infra Consulting, End State Solutions, and Grand Sky, without which this show would not be possible. So we thank all of them for sponsoring some of our other streams and therefore indirectly sponsoring this newscast as well. Okay. Let's get to our experts and then let's get to our articles. So let's go around the horn. We've got Karson Kall. He is from WISPR Systems. So Karson, tell them a little bit about yourself.
Sure. Nice to meet everybody here. Come from a background in civil engineering, practicing civil and structural design. Began using drones on elision cases. So where a ship strikes a fixed object, such as a bridge, and then topographical survey sometime in around 2014.
Awesome. Well, great to have you on the show. We had John MacArthur on the Dawn of Autonomy podcast recently, and also released that Sky Scout 2 Plus series, and really awesome stuff you guys are doing over there at WISPR Systems. All right. Justin Thomas is from Exyn Technologies out of Philly, my hometown. So great to have you on the show, Justin. Tell them a little bit about yourself.
Thank you so much for having me, John. So my background is, I guess I first got into UAVs around 2000 or the early 2000s as a hobby, and kind of hijacked my path and took me into eventually to a PhD in controls and motion planning for UAVs. So that's what I'm now doing. I've been at Exyn Technologies for about 8 years after completing that, and I'm focused on controls and the motion planning aspects of our autonomous systems.
Well, I love that. I love how you said drones kind of hijacked your career path, because I think I can say the same, honestly, when I was in the Air Force. But it's what a great journey it's been. So that's really cool. All right, Pramod Raheja. Pramod is with Airgility, and also, fun fact, is our writer for Autonomy, our ambassador for Autonomy Global. So, Mode, great to have you on the show.
Thank you, Don. Appreciate it. Happy to be here and talk all things autonomy. So, yeah, I am also a, let's see, I'll call it a longtime entrepreneur and aerospace geek. So I really do get into all of this stuff and what the future holds. There's a big aerospace evolution and revolution going on. And at Airgility, I'm the CEO and co-founder, and we really focus heavily on autonomous systems and GPS denied, or really any type of environment. Got our start working with DHS, trying to build robust technology in that type of environment, and now focus heavily on DoD missions around CBRN and CWMD, and that's our big focus areas right now. Thank you.
All right, awesome. We're going to start with our first article. Now, this is Karson's article about CHC navigation and how network RTK enhances global position accuracy. So, Karson, tell us a little bit about this article and why you selected it.
Sure. So this particular article deals with not necessarily, it's ground control. We're getting corrections to GPS, and we'll kind of back into that in a second. And instead of having to utilize a base adjacent to us or utilize a network system of bases, because sometimes people do not have Wi-Fi or cellular capabilities at sites that they may be at to collect data, we're starting to see this augmentation where we're seeing satellite-based corrections come down in the data stream. And it kind of made me think about things and wanted to back up and provide a little more of like some acronyms here and kind of how things are basically working, and then jump back into the article. But it's something I've been asked about a lot lately, and it's certainly piquing the interest of a lot of different groups. So we're all used to hearing about GPS, the global positioning systems with the geosynchronous orbits around Earth. But a lot of people forget that it's really the GNSS constellation, that global navigation satellite system that we're talking about. And that comprises of multiple constellations. So not only GPS owned by the United States, but GONASS, Russia, Galileo, European Union, Beidou, China. And then we have a couple others that are coming online that we typically don't get or utilize here, but kind of wanted to back into that first. And the whole idea is we're getting these signals from space and they're being distorted through the ionosphere. The atmosphere has a huge impact with the humidity, temperature, cloud cover, et cetera, on how those waves propagate and hit the antennas. And what we're seeing and have always seen, shouldn't say that it's new or anything like that, but you have this distortion effect. So the accuracy is not necessarily survey grade. And I say survey grade, think of a golf ball. We're trying to get our XYZ points all within that golf ball as a repeatable pattern. So what we have typically utilized is a post-process kinematic solution where we take base observations, and this might be a satellite that's sitting over a known point collecting static data. It knows where it is at any given millisecond, and you're comparing it to that of the rover, in our case, the drone, but in the survey world, an actual rover, another GNSS head on a pole typically. And you're able to get those corrections. Hey, base, where were you at the given millisecond? Okay, so I was supposed to be over here. We're used to doing it in that sense. It became more popular. I would think, well, when I was first exposed to RTK, it was in about 2003. And it was pretty primitive then, but we were able to get this real-time kinematic solution so that our software can display a corrected position on our rovers, or our drone could record the positional data corrected at the given millisecond of the camera trigger. Then what we started kind of seeing come out most recently is more of this, I call it more on the PPP, the precise point positioning, where we're getting ground-based satellite systems that are reading the GNSS waves and providing those corrections back up through a satellite link. This allows us to not have a local base next to us. That's a piece of equipment that needs to be set up correctly. Most of the time we set those up over a known point, if not resolve it as a known point afterwards. But it kind of wraps it all in so that you're just having a clear view to the sky and receiving corrections. And that's what kind of brought me over to the article. There's a couple of companies out there. It's not necessarily just CHC navigation that has something of this. Even GPS has something called SBAS, which is ground-based corrections that's augmented through the satellites. Trimble Centerpoint RTX might be one that some have heard on this call, but CHC navigation has theirs, and they're calling it SWAS, the Satellite-Based Wide Area Augmentation Services. And the idea here is I don't have to be within a ground-based area that has connected bases through a network that's providing either real-time corrections or post-process kinematics, so I can get that base data afterwards. Because now we're having to check out the site to see where we're located. Hopefully we're not any further than 40 kilometers from any given base, ideally in the 10 to 20 kilometer range in a normal RTK network. And you want those to be kind of triangulated around there. You want to have the 3 bases around your position. Whereas where I'm from down in South Louisiana, it's coastal. So sometimes we don't necessarily get within that triangulation pattern, and there might just be a base that's within one set distance over there. So having the ability to have this data streamed by another satellite, a geostationary satellite above us, really opens up our survey abilities, our drone accuracy abilities in the near future when more of this kind of becomes more common across the industry. But you're seeing that not only is it less equipment, it doesn't necessarily landlock you. You're not depending on a wireless system or Wi-Fi. It's kind of opening up things to where we can go, and also what kind of accuracy we can get from there. When we first were able to do this, we're in the neighborhood of 3 foot vertically, and then it became much tighter. There in this article itself, they're talking about a 3 centimeter horizontal and a 6 centimeter vertical accuracy by using this augmented surface. And that's just, to me, phenomenal that we're getting down to that range without any ground-based stations, without any network correction services.
Yeah, I mean, that is amazing. And, I've seen CHC navigation. I see them every year at Geo Week. I know they've got some interesting maritime vehicles, if I recall correctly.
That's right. They do.
that they're putting out as well. So interesting that they're leveraging, they have like a satellite apparently they put up for this SWAS satellite-based wide area augmentation service that they're now offering. We're going to get into it more shortly with Justin's article. I'm going to go to Justin next, because I'm curious what you guys think in terms of just having this entire, let's just say, process all space-based, because, we're seeing a lot of attacks in space. We're seeing spoofing, we're seeing jamming, other issues with weather and things we're going to get into with Justin's article and some other, kind of things closer to the ground to help correct those. So it's interesting that, Karson, to hear that CHC Nav is like, hey, throwing it all up in space, and like, hey, this is better. Justin, I'd love to hear your thoughts. I know I don't want to jump ahead to your article. We're going to talk about that in a second, but I always find so interesting how, we don't have people pre-coordinate their articles, but they always seem to have a weird thread. And I feel like that's the thread here, like the role that space is playing or not, and should or should not be playing.
Better way of saying it there.
yeah, in terms of navigation for autonomous vehicles. So Justin, over to you.
Yeah, I think this is very fascinating. I am particularly curious about the real-time aspects of this. So as someone who develops autonomous systems, one of the things that I care about a lot about is latency. And if you're going to capture a data set and then post-process it so you can get a survey, that's great. We don't really care about latency in those scenarios. So I'm curious if you have any insight, or if anyone on this call has insights into what the implications might be for a real-time system operating autonomously.
Karson, I don't know if you wanted to answer that, and then we'll go to Mo.
Sure. And it's pretty quick. Not on the drone side yet. This is kind of a newer technology that's a lot of people are talking about rolling in and getting more involved with the drone side. But on the rover side, I've had the ability to test with a different company, not CHC Navs, but another company from that side of the world. And surprisingly, we were getting pretty consistent results. The horizontal was locked on. The vertical was, it was about twice the accuracy of the horizontal. But it was working. It's not survey grade. It's more like on the GIS side of things. But I was surprised that kind of blows everything that I've been taught and had learned before and have experienced. But I agree. I mean, now you're having to get waves from the satellite constellation down to the ground to a base that's still networked, that is being uplinked to another satellite to be able to be downstreamed. That's a lot of movement. And I mean, we're already trying to account for that ionosphere and atmosphere with the distortions, and that it's taking the waves longer, and that we have timing issues and atomic clock issues. So I'm curious to see how it all actually plays out once fully in effect.
Yeah, really, really interesting. Mode, what are your thoughts?
Yeah, I was just gonna really add to what Justin asked, which is really, I think it depends on the mission, right? What are you doing, and obviously real time. And some of the stuff I'm going to talk about, or as we get to the third article, there's some things that happen real time where having the ability to operate in the GNSS denied environment is very, very important. So that's all I was going to add. It just really depends. I know some of the applications in regards to what Karson's talking about are really around, commercial applications and maybe some precision agriculture and things like that, that maybe you don't need it real time, but you do need the data, but maybe it doesn't need to be real time. So it depends on the mission.
Yeah, interesting. I mean, I think there's so many creative solutions coming out in this space. Here we've got a satellite-based one. I was just at the Tennessee Drone and AAM Symposium last week, and Intera was there, and they've built this, what do they call it? It's like the smart something. It look, do you guys know what I'm talking about?
TAP is their solution.
Yeah. So you basically put it on the ground. It looks like it's smaller than a third base, cushion, and and they have their own system that accounts for that. So if the government-wide system, I think it's PPK, if that all goes out, the mission can still go on. So it's really interesting. I think the gaps that people are filling with their technology, and here's a space-based one, and this one is cloud-based too. Like in terms of, we were talking about the uplinks, the downlinks, and all the movement here. It's also like using models in the cloud, I think, to account for the accuracy. Is that right, Karson?
So I'm not too sure if Taurus, if the TAP one, if they use it. And the CHC Nav article does not state that it does or not, but I know that the Trimble Centerpoint has some ties in there. I don't know if they're using data directly from there, if it's just ephemeris or like a prediction of where these satellites may be. That's a good question.
Yeah, I thought I read, I don't know, maybe I'm wrong. I thought I read cloud-based ionospheric and tropospheric modeling minimizes that signal distortion. And so like they were using some kind of a cloud-based modeling for this system. But regardless,
I'm following you. My apologies. I'm thinking of a cloud-based storage / database /
oh yeah.
Not necessarily the ionosphere atmosphere. Yes, absolutely.
Yeah,
absolutely.
So really interesting. We talk about like, we always say on the edge, it's on the edge. I mean, this is like on the space, edge in space. Yeah. So really, really wild stuff here. And by the way, everybody, if you didn't know, I mean, this is really critical for precision surveying, mapping, precision agriculture, construction, of course, that ACE crowd of architecture, construction, engineering, the ones that really need those hyper precise measurements, especially if they're going to be using drones to help gather that data. So really, really cool. Thank you for sharing this, Karson. I mean,
absolutely.
I know the Department of Transportation for a long time now has been looking at, what are ways that we can augment PNT, position navigation timing. They were looking for more ground-based solutions, although they didn't rule out space-based solutions. It's interesting that here we have a private company, just really in this, kind of, look, I'll call it drone, but more autonomous vehicle space, that has decided we're just going to throw up our own augmentation here. We're going to throw it up in space. So really, really cool. I think governments are looking for solutions, not just private industry, not just enterprise users. So it'd be interesting to see if this is something that could be more broadly leveraged in some manner. But thank you again. Let's go to Article 2. Okay, so our second article is actually Justin's, and probably a great segue here because this one is about, GNSS denied unmanned aerial vehicle navigation, and it's a report that analyzes computational complexity, sensor fusion, and localization methodologies. What a mouthful. So I'm going to go ahead and Justin, have you explain what this thing is all about and why you actually picked it, why you think it's so important.
Sure, thank you. So I think it's a particularly relevant article because it is looking at GPS denied situations, which is something that personally that we deal with a whole lot at my company. And the reality of the situation is that you don't always have access to GPS systems or GNSS systems. And sometimes even if you do, the information that you're receiving is not useful or precise enough.
And Justin, can I interrupt for 1 second? Just to be clear with everybody, Exyn Technologies actually is sponsoring the entire month of November on the Dawn of Autonomy enabler. It was October, excuse me, and it was Mission Enablers Month. And so you said your company focuses on this area. Can you explain why basically you're creating systems that can work in mines and other places that are GPS? I'm not even talking about spoofing and jamming, just GPS. There are a lot of GPS denied environments on Earth. Can you explain some of that?
Yeah, absolutely. So a lot of our customers are underground mining companies. And the way that they're operating is that they are creating through blasting methods large caverns underground, and they need to be able to survey these and understand the formations, the shapes of the underground mines, and so that they can plan their mining operations for the subsequent blasts or for the extraction of the ore. And so this autonomous capability is necessary in those environments, but there's no realistic way for GPS to be useful there, because sometimes these are kilometers underground. And so the signals from the satellites are not going to be able to penetrate the Earth that deep. And so the autonomy is still necessary because they need this information. But this is really ends up in a scenario where the vehicle does, and I can transition back to the article too, because I think this is part of the reason why I selected the article. But the autonomous vehicles end up localizing using relative methods. They can figure out where they started, figure out where they're trying to go, and use all of that information, but only locally. They don't know where they are in the grand scheme of things on Earth. They're figuring out how to navigate the world using only local information. And later, the connection can be made between where the vehicle is underground and actually where it is relative to the Earth. And so you can actually tie all that back in to your Earth coordinate system with whichever survey method of choice that you would like to use.
So, Justin, that's the relative localization. Now, absolute localization involves position, giving a position directly in a global fixed coordinate system like lat, long, altitude, in an Earth-centered frame. For example, what GNSS provides. So what you're talking about is this kind of relative localization in places where, GPS or GNSS is not going to penetrate. Those satellite signals are not going through a cave or a mine. And so you're looking at what, visual localization techniques? And if so, tell us a little bit about, I know you guys use SLAM, SLAM, that's something that Exyn Technologies, has expertise in. Can you tell everybody a little bit about those methodologies and what the article says about them?
Yes, certainly. So I'll start off with what Exyn does, and then I'll switch over to the article, which is a little bit broader than what Exyn's technology is. So we use LiDAR-based methods, and it is SLAM, simultaneous localization and mapping. And so what our autonomy systems do is they're constructing a 3D model of the world that they're in, and simultaneously using that model to figure out how the vehicle is moving in that world, and using that model to extend the model. So you can imagine a vehicle starting in one location, and as it moves, it can perceive more of the environment. It is using that new field of perception, that new view, to extend the model that it's already created. And so that's how our systems are able to use LiDAR. They're scanning these 3D point clouds at very high rates, thousands and thousands of points per second coming in, and we're using that information to build and extend that model. Now, the article looks at, Don, as you mentioned, the absolute localization and relative localization. It broadly categorizes these methods of the vehicle understanding where it is. It broadly categorizes those into the two categories of absolute and relative. Absolute would refer to anything where the vehicle is figuring out where it is relative to some known world coordinate system. This is traditionally your GNSS systems. Whereas relative localization is where the vehicle doesn't actually need to know, or doesn't maybe just doesn't have the ability to know where it is in the world. And so instead of figuring out where it is on Earth, it's figuring out where it is relative to where it started. And so that relative aspect of localization is that second category. Where is the vehicle relative to either where it started or some other reference system that it is able to establish prior to flight?
And it kind of runs through a whole bunch of different technologies, both absolute and relative. I think relative is kind of the more interesting one in a way. But does it ultimately conclude that multi-sensor fusion is kind of the way to go in terms of look, that just makes an abundant amount of sense. I'm just thinking about the counter drone world, right? It's just like there's no one bullet, silver bullet, right? It's just Absolutely. Like we need a multi-layered defense there. And that's the parallel I'm making right now as I think about this article, that one sensor only gives you a certain perspective, but if you can incorporate LiDAR, radar, other sensors, you're going to get a better view and determination of where you are.
That is 100% correct. And one of the interesting things, though, is for relative, I think that has been well established for quite some time, because anyone who's doing relative navigation, I think, understands the limitations that every single sensor has some drawback, right?
Yeah.
And so, like, we use LiDAR and it works very well for us, but there are situations where maybe vision is better, or radar is necessary, or maybe sonar is helpful. And so there are different scenarios where different sensors have their pros and cons. But one of the things that this article also explores is the possibility that even these absolute methods that, I mean, we're talking about GPS or GNSS systems here, but the article also explores other methods that are using, for example, topography of the Earth or visual texture of the Earth. So once you've established your location on Earth, you can then use another sensor that's not GPS based at all to figure out how the vehicle is moving and match that back to a prior database. So even if you don't have, even if you're operating with absolute or relative, in both of these categories, it's helpful to have the multi-sensor aspect, because you could be denied the ability to use your primary sensor at any point in time. And having that flexibility to be able to fuse all that information together to improve the estimate of your location really goes a long way to improving reliability and accuracy and precision.
Oh yeah, absolutely. Mode, I'm going to go to you, because as I think about sensor fusion, and I know that the term deep learning was mentioned in this article. I know that's something you've been working on. I mean, I've seen demos of some of your drones, like in the dark, navigating in really weird places. Tell us a little bit about, your thoughts on this article.
Yeah, well, first of all, I would say Justin is absolutely right about, I would call, a hybrid fusion of sensors being the future. So like Exyn at Airgility, we also do a lot with LiDAR, and it's very powerful. LiDAR is a powerful sensor. But if you look at also, like, a great example I'll give is that most of our audience probably will be familiar with. If you look at what's happening in the world of driverless taxis, why is Waymo so far ahead of, say, what Tesla's trying to do with taxis? They employ a hybrid fusion. They have LiDAR. They have several LiDARs on board, and the most prominent one is the one sitting on top of the car, of course. And then they have about 10 or 11, I don't know how many cameras they have, but they have quite a few cameras, and they also employ some radar. I don't know much about their radar, but they're using all three, and they're expanding their footprint all over the world with that, most specifically in the US, but I think around the world as well. Whereas I haven't seen any other company in that world of driverless, taxis really be prominent. And if you look at Tesla's as an example, they completely use a visual solution, which is, and as Justin mentioned, every one of these sensors has some limitation. And the article says that as well. So hence a hybrid. So I strongly believe the future of what we're going to see in whether it's drones or cars or trucks. I know people that are, working, leading the charge at Amazon for driverless trucks, for example, and it will tell you the same thing, right? It's really a hybrid fusion that is the future, and those sensors are going to continue to get better. The algorithms around those sensors will continue to get better, but they'll have to work in concert with each other and with the sensors on board as well.
Yeah, I mean, look, I actually have a Tesla, and I live in Colorado, so to get some snow out there, some slush on the road. Now, luckily, there's a lot of sensors around the whole car, so when one or two of them gets blocked, the whole thing doesn't just shut down and stop driving. Although I wouldn't put it past my car to do that at some point. But so far, God willing, it hasn't happened. So Karson, I'd love to hear your thoughts on this article.
Sure. Oh, absolutely. I mean, even with our navigational systems, for example, we're blending multiple sensors. So you have RTK injection, GNSS, you have the barometers, and then you have the IMUs. Now, we're not going in non-GNSS denied environments for other reasons, but all of those sensors are together on a network. And when one is not agreeing with the others, perhaps you're getting bad data or something is wrong or blocking that sensor, and you kick it out because you have another set of backup. It doesn't come necessarily into the redundancy where you want to have, like, triple IMUs, for example. You want to have multiple systems, and that's exactly what we're seeing with the vehicles. Out here near San Francisco, and I followed behind one towards the Golden Gate Bridge just yesterday, and it was fascinating to see the amount of actual cameras on there. Whereas I'm used to thinking, oh, it's LiDAR, it's LiDAR, it's LiDAR. But you're right. They're injecting multiple systems for that reason.
Very, very cool.
So,
Justin, I'm going to give
really
you
cool.
last word on this. I was going to give you last licks on this article if you had any closing comments for it.
Oh, for me?
Yeah, for you.
Sure. Yeah, I do. I appreciate this because there's one big thing that I think the article grossly overlooks. And that is that these methods are all about localization. But when I think of navigation, I think of navigating around obstacles. And none of the absolute methods really allow you to do that directly. And so I think a lot of the relative methods, because they are perceiving the environment and using motion in the environment to figure out the motion of the vehicle, they kind of indirectly allow you to build a model of the obstacles that are in the environment. And that's important because if you're using the absolute methods, they're only as good as the data that you have prior, or the data that you're able to update. But I don't really see that happening right now or happening yet. So for example, if you're flying at low altitude and you want to fly under a tree canopy, GPS isn't all that helpful. Even if you have the GPS signal and it's reliable, it's not going to tell you where a tree is. And so these other methods of sensors are really what I think we need to start incorporating into these systems if you want to be able to operate in those environments. Obviously, it's very application specific, and so I think that you have to evaluate that when you're deciding which technology to use. But I really think that the future is going to be a fusion of all of these methods, and lean into the strength of every single one when you have that opportunity.
Yeah, very, very cool. I mean, we're really kind of doing, I think in terms of the alphabet PNT, with Karson's article, we were really locked on the position, if you will. And then Justin, yours is more about navigation, although position is a part of that, as well as timing. But, it seemed like more this was a navigation article. So thank you both, for kind of, when you think about autonomous vehicles and autonomy in general, PNT is so critical. And so, how are we doing that? Whether for, precision agriculture and that exactness of where something is in terms of measurement versus, actually navigating the world in places where the GNSS signals are not going to get to. That's what this has been all about so far. But we're going to really, kind of change it up a little bit and switch to really policy and ethics here in a second on the defense side with Mode's article. But before we do that, I wanted to once again take a second to thank our sponsors, Rollins Infra Consulting, End State Solutions, and Grand Sky. So thank you guys for everything. Really appreciate you and making this show possible. All right, Mode, your article is all about cheap drones, expensive lessons, ethics, innovation, and the regulation of autonomous weapon systems. So talk to us about this one.
Yeah, so I chose this article, the impact and relevance of what's going on right now with regards to defense and how drones and autonomous systems are being used is changing rapidly. Let's take us back a few years to where we were in the US, at least, using very expensive systems on the drone side. Meanwhile, everybody saw the Ukraine and Russian war, the most what I would call visible war ever in the world that we see on the internet every day. And every day there's a new drone video or something along those lines that show something new. And to give you some examples, and I'll state the obvious, they're extensively deploying drones on both sides. They're developing advanced targeting capabilities, operational advantages, and all those kind of things. And the best example I could give, and there's many, but June 1st, Operation Spiderweb, Ukrainians attacked Russia and they targeted some of their Air Force bases. That was, believe it or not, although I would say Justin and Karson and many in the industry probably already knew this, but for many in our government, that was a wake-up call. Although we kind of already knew this was possible and was probably going to happen at some point in one of these conflicts. But that was a huge wake-up call. And then shortly after that, you saw announcements around drone dominance and things like that here in the US, like maybe a month later, I think it was about exactly a month later almost. And so I chose this article because we in the US are very cognizant, historically at least, of ethics and on the battlefield. Meanwhile, our adversaries, I would propose on this call, are not necessarily thinking about that as much. So autonomous weapon systems are starting to be deployed. Autonomous targeting, where you don't have we talk about humans in the loop, humans on the loop, and now, unfortunately, humans out of the loop as well. So again, using some simple examples for our audience, think of the movie Terminator. If you've seen the Terminator movies, Terminator 2, going back. And one of the most recent examples, which is still a fairly old movie, is Angel Has Fallen, which is Gerard Butler. He's in all of those types of movies. And if you Google that, you will see, just Google Angel Has Fallen drone scene. And at the beginning of the movie, there's an intense drone scene that I will tell you and I will argue with you that is the future of drone warfare. And we have to defend against that. So I'll stop there and pause there for discussion and questions. But yeah, I chose that article because of all the things going on right now that we can see in the news every day.
Wait a minute, Angel Has Fallen. Is that with Morgan Freeman and they're on the boat,
Yes.
like the Potomac, and the swarm comes and like they're jumping off the boat like into the water and hiding underwater? Oh,
that's exactly
crazy.
right.
Yeah, well, look, you don't even need to watch a movie. I think there was a Geico commercial or one of those insurance companies where all these people after work were like huddled in the lobby and they're afraid to go out to their cars, and like they go out and all of a sudden the drones start swarming them. It's just like, what is this about? But no, I mean, that's where we are today, right? And when you think about autonomous weapon systems, Mode, I think, they use the acronym LAWS, which I think is ironic. LAWS,
Yeah.
Lethal Autonomous Weapon Systems, and how, the concern is, they may very well lower the threshold of war. And what was really frightening to me, I thought, was how the DoD changed updated their directive 3000.09 in 2023, just 2 years ago, that redefined human oversight as operator oversight. So what does that even mean? Does that mean, AI entities can have a supervisory role in these, situations? I mean, as a former JAG that gave advice to commanders on the law of war and, targeting, that's a little troubling. So anyway, Karson, I'm going to go to you next. What are your thoughts on this article?
It's fascinating because it just shows how much more we can do, how much more we probably should be doing by lessons learned and watching what's going on overseas. I also find it fascinating, we're talking about non-GNSS environments, and that you're seeing a lot of the fiber optical connections between the pilot, I guess you would say in this case, and the drone itself. So yeah, I think there's a huge need. There's definitely a void there. There's monies that have been appropriated for it. So it's going to be interesting to see what some of these American manufacturers can come up with.
Yeah,
put on the shelf.
Absolutely. I mean, look, technology always moves faster than policy, law, regulation. We know this. We've seen this on the commercial side, and of course, on the defense side, if we're deploying laws, if you will, and how is that really going? So, Justin, what are your thoughts?
Yeah, first of all, I'm really appreciative that we have articles like this that are unpacking the morality of decision making here. I don't know that I have any. Well, let's say this: I'm not going to express particular opinions one way or the other on these systems, because I think we need to approach this as a society from. We need to challenge everything, and so I think that it's important that we have things like this that are really starting to unpack it. That being said, I agree 100% that we need to explore this from just from the fact that if our adversaries are, then we need to be able to understand that and understand how that is going to impact us, and be prepared to counter that. And again, I'm not going to take a stance on what that looks like, but I do think it's important that we understand.
Yeah, I mean, Mode, I'd love to hear your thoughts. I know you're former Navy, is that right?
No, I'm not. I'm not.
You worked with the Navy. I'm confused. I know you have general aviation background and you started flying when you were very young. But when I think about this, to use your words, Justin, I think it's almost easier to get my brain around some autonomous system making a decision to counter something that might be in the air if there's no humans on board that thing. In other words, if I have a counter drone technology and it's going to leverage AI, it's going to rapidly assess, like, is this a legitimate target? Is this going to, harm what I'm supposed to protect, essentially? And that thing doesn't have humans on board. You're just blowing property out of the sky. Again, depending on collateral damage and what could fall, I'm a little bit more comfortable with that than like an autonomous target system that can target humans and on the ground, or even property on the ground, especially from the sky, but could be from the water, right, from the sea, really any domain, because I think there's just so much more risk of incidental damage, collateral damage to innocent civilians, in situations like that. Mode, what are your thoughts? Bringing it back to you for this article.
Yeah, look, I think we're in the early innings of these lethal autonomous weapon systems. Right now, if you look at what's happening, there's a lot of fiber optics, as Karson mentioned. They're using FPV, or first-person view drones. And what's happening in Ukraine right now is really every 6 weeks, maybe even faster than that, there's an innovation cycle, something new, something that they're trying. And literally, it's a high stakes hackathon. You wake up in the morning and you say, okay, that didn't work, and my comrade died. I need to fix something and make sure we don't get targeted, for example. So if you talk to Ukrainian soldiers, they will say, we are flying 12 hours a day, flying FPV or fiber optic drones. But that is not the future. FPV obviously takes a lot of training. It could take 6 weeks to a couple months to train somebody fully up. And an FPV, obviously, not FPV, but fiber optics. Also, think about the miles of cable in the environment. That is also probably not the future. And so autonomous systems absolutely are. So it is happening, and we are in the very early innings of it, even though we're seeing some interesting automation and autonomy start to take place, that we're developing, that I'm sure Justin's developing, and we're seeing in other places as well. But yes, that's how I would wrap it up. That we're in the early innings of this game, and it's going to require a lot more conversation. And if you think about it, $34 billion is going to be spent on autonomous systems this year, globally, and the United Nations and others are starting to get involved and say, hey, we got to talk about this. So that's where I think we are, and there's still a lot to talk about.
Yeah, and when you think about the 3 articles and kind of the thread here, it really does all come down to position, navigation, and timing. Because
Right.
if you've got especially a lethal autonomous weapon system, it's going to deploy something on a target. It better actually be putting it on the right target, in the right location, at the right time. I mean, so you can see how what Karson talked about. Like, is there a satellite augmentation system that can help in terms of that, or Justin's article, what do you do, as visual, LiDAR, like what do you do in terms of GNSS denial and all of these things. So not just for the thing that's flying, but like maybe for where it's going to, lob something down on something else. So really interesting how it all came around to almost like PNT in the show in a way. But I want to take it up a level, and then I want to close out everybody, to have everybody give their final thoughts and tell everybody how they can reach you after the show. But as a military JAG, I mean, even when we were using, and they still are, of course, the Global Hawks, the Reapers mode, what you kind of referenced as very complex, very large, very high altitude drones, and we've been using those for a long time. there's always these questions like, well, how does that comply with the law of war? The law of war is written, it's international humanitarian law. It's written very broadly. And so there are just general principles. And, so whether it's a lethal autonomous weapon system or something being remotely piloted or piloted actually by a human directly, like in an F-16, as an example, the law doesn't change. It's principles like distinction. You can't be targeting innocent civilians, right? It has to have a military purpose, right? So I'm not going to get into that lecture here. There's lots of great stuff. And by the way, if you care about international law or you want to learn more, the International Committee of the Red Cross, the ICRC, has an amazing website that with lots of great materials to educate yourself on what those rules are internationally, because we're seeing targeting of ships and other things. And what people are questioning, is this even legal? Check it out, read it for yourself, educate yourself. But really great that you brought up not just the technology mode, but the ethics of it all. And what does this look like in the future? So thank you so much. All right, guys, we're going to go around the horn. I'm going to thank our sponsors one last time, Rollins, Grand Sky, and End State Solutions. And Justin, we'll start with you as we go around the horn here to just any concluding remarks you have, and certainly how people can learn more about Exyn Technologies and how they can possibly reach you.
Sure. If you want to find out more about Exyn Technologies, you can check out our website, exyn.com. Also, you can email me, Justin Thomas, jthomas@exyntechnologies.com. All
right, awesome. Thank you so much. Karson?
Sure. It's going to be interesting to see what comes up next. That's what kind of gets me excited. I certainly think that the non-GNSS environment is going to be explored a little bit more by everybody. So I'm just really excited to see what's going to come up next and what ideas and what's being tested. As far as contact information, I'll put it in the chat. Kall@wisprsystems.com is my email. Of course, wisprsystems.com is the web address, and I'll go ahead and throw my phone number on there, which is 985-373-2698.
All right, very
awesome.
good.
I appreciate the conversation, guys. I enjoyed that. That was fun.
Yeah, it was really, really interesting. And last but certainly not least, Pramod.
Yeah, thank you. I'll just close out with what we were talking about with the autonomous system, especially in the defense and warfare world, are going to be balancing operational efficiency, think cheap, as cheap as possible, economies of scale, and then balancing that with the ethical imperatives we talked about, and maintaining that sort of human agency. Do we do that in lethal decisions? And then obviously, Don, your world, embedding these legal safeguards into the design and regulation of these things. Where does all that fall? So that's what I'll close out with. And I'm easy to reach. I'm on LinkedIn, and Pramod, my first name, at airgility.co, not .com. Feel free to email me. And of course, our website, airgility.co as well. And I appreciate it. Thank you.
Yeah, and by the way, just closing shameless plug, Law Tech Connect 2026 with AVSI Exponential. It's going to be in Detroit in May. 8 panels exploring the legal policy implications of various technologies. We're absolutely having an AI panel this year, so that should be really exciting. That actual registration website is already live. My faculty is underway, not fully filled, but working on it. So hope to get some more information out in the beginning of the new year. By the way, everybody in the United States, if you're celebrating Thanksgiving, happy Thanksgiving to you. Have a wonderful rest of your week. And we are now entering into that holiday season. I will say this is going to be our last full crew of the year. We're going to take a break in December and jump back in full force in the new year in January with robots. So make sure to stay tuned and follow autonomyglobal.co, like Pramod's website. It's not .com, and stay up to date on all the latest. So thank you all. Really appreciate you. We are out here.